Good morning, everybody. My name is Lance Vaughn. I'm the CEO of CABboard. We build web and mobile applications. I've been in custom software development for 30 plus years. Today's talk is about understanding and implementing rugged. This is a pretty abstract, high-level thought. What we're going to do today is try to be a little bit less abstract and talk about some real-world examples, give you some specific items that you can then turn around and apply in your own life, apply in your own software at your own organization. At the end of the day, rugged is about software that is secure and reliable and maintainable. Those are the top three level things. I studied a lot of Steve Jobs, and he always tried to take any concept and every event and boil it down to three things, so that you could something you could walk away with. And if there's nothing else that you get from today's discussion, and if you want to go ahead and leave early, those are the three things right there. So let's get into a little bit more of the detail. But before we do so, let's talk about the challenge of being rugged. I've never really been a huge fan of Batman. I've got 3 boys at home now, ages 2, 4, and 6, and they're in their kind of superhero stage. And I've been doing a lot of thinking about rugged and what it means to be rugged and to live rugged on a daily basis. And Batman, in my mind, kind of personifies what that is. But Batman, of course, as we all know, is a fictional character. Bruce Lee, however, was a real-life character, and there's many others out there that you could pick, but the reason I picked Bruce Lee is because he's got some great art, but also because he really exemplified a top-notch martial artist. I have a little bit of martial arts background, and one of the things that we do in martial arts is we step through a lot of katas. We do a lot of practicing, a lot of sparring. And that is one of the number one premises of rugged, is that we're constantly practicing and sparring and learning, challenging one another. I almost put up a slide about the Fight Club, the movie Fight Club, because that's what it's all about. Setting a standard not just for yourself, but for your peers and your organization, those who you work with on a day-to-day basis. And doing so out of love and respect, and the fact that we need to command and demand more from ourselves and more from each other. The whole rugged movement kind of got started in about 2010, 2011. I found these slides from 2012 that was suggesting that there are some rugged attributes that you could break down and discover more about what it means to be rugged by exploring some of these attributes. And there's something about my personal makeup, the way that my brain works, is I really resonate with this idea of trying to capture a particular aspect of a system and identifying it as being good or bad, and then either accelerating it or decelerating it. But my point being is that there were only 6 attributes back in 2012. And along with James Wickett, Josh Corman, Matt Conda, I've been spending a lot of time thinking about them, and we've continued to tweak some of them and add some additional attributes. But I think most importantly is we started grouping them together, because being in the software business and trying to explain rugged to my customers and even my employees, if you just start listing off 10 plus attributes, their eyes just glaze over. And so that's how I recommended that we just embrace secure, reliable, and maintainable. But you can't just stop there. You have to go to the next level to understand what to do with those. And so what we're going to do today is we're going to step down through each of these, talk about a couple of examples of each of them. This is totally wide open. Please feel free to stop me at any point, ask questions, or if you have a good example either in software or in the real world, please raise your hand and let me know. So first we're going to step through the various secure attributes. And one thing I would like to point out is I am a lifelong software developer. I don't come from a security background. And I already shared with you that I've really resonated with the idea of these attributes. But I don't have a security background, so I have a little bit of a difficult time understanding how to break out security into something more than just defensible and sensible. So if this particular topic interests you, this would be a great, and if you have a security background, please feel free to jump in. There's areas that we can contribute. And I think you'll start to understand a little bit more about why we want to do this. So the idea of something being secure, protected against attack or other criminal activity. There's not much about security today that I can teach you that you don't already know. But at the end of the day, our customers are trusting us with their data, with their information, with their transactions, with their commerce. And we need to do everything that we can do to secure that transaction and to secure that data. Defensibility was in fact one of the original attributes, and the original idea for defensibility is that an application should be able to identify when it is being misused or abused and immediately react to that, theoretically like a DDoS attack, something along those lines. But I want to suggest to you that the idea of defensibility, or a system being defensible, is a lot more interesting than that, because that's what I think the fear is in my mind of looking at the world through just a lens of security or through just a lens of software. Is we're forgetting to open our minds and think about all of the other different possibilities out there. So for example, when we look at some of the older architecture in Eastern Europe, this is a highly defensible structure because it is simply very difficult to get up to the point where you can actually get access to it. Perhaps a little bit more applicable to our lives today, understanding your threats, understanding your enemy. And in this particular case, the threat is wildfires in California. And so they attempted to put a multi-million-dollar home up on the top of this hill and create a defensible perimeter. As you can tell by the nature of the state of that particular home, it didn't work. And in this particular case, embers from the fire were rolling along this sandy structure and then up the hill because there was simply nothing to stop the embers. So it wasn't the fire itself, but the remnants of the fire. If you're a big fan of Star Trek, we all know about the idea of shields. Shields almost never worked. In fact, when they worked, it was pretty boring. So, and it's much more interesting when they don't work. And so if you think about something like the shields to protect photon torpedoes, well, that almost always worked, assuming something else wasn't broken on the ship. But frequently, they would run into enemies that weren't shooting them with photon torpedoes. They had yet a new weapon, right? And so understanding your threat and having a defense for that particular threat is a good start. But it's not where it ends. Understanding the fact that our enemies could in fact be potentially more agile than we are. And then the third attribute that I've put under security is sensibility, or the act of being sensible. Processing or displaying sensitivity and prudence. So an example of this would be just the idea that software itself should be able to, similar to defensibility, should be able to detect how it's being used, but then to have the sense to know how to respond to that potential misuse. And we'll get into that here in a little bit more. So here's an interesting example of this is actually not really a cannon, but it's just an ornament, but it's an interesting example. So this is not a cannon that I would want to protect my castle because it is in and of itself impossible to use due to its size. The point being here that you wouldn't necessarily, even if this were a real cannon, want to use this cannon if the particular attack weren't of equal measure. So if someone were just loitering on your property, certainly that would not be the appropriate response, nor would an intercontinental ballistic missile. So there's this idea of, in the military, of symmetric response, or perhaps more interestingly is asymmetric response. So meeting fire with fire, supposedly, right? And so in the military, there's a lot to be learned about the science behind, given this attack, we will respond with these measures. So here's an example of asymmetric response. So can you find your enemy in this picture? Well, it's too late, you're already dead, right? Asymmetric response, terrorism. So there they are, and he's not alone. Even if you saw him, this guy would have got you. So now let's move on to reliability. Anybody have any comments or questions about security? Okay. Reliable. So reliable is a attribute that we added. I have an uncle who has a doctorate. He's a professor up at Baylor University, and I went and talked to him about rugged. And he introduced to me the idea of reliable software. And I guess reliable software there was a really big push for it in the 90s. It was, I guess, the rugged of the 90s. But it was something that I had never heard of. They didn't teach it to me in school. These are the types of things that we have to learn in our regular everyday job. Unfortunately, we're getting paid to learn by customers who we should be better serving. Reliability is consistently good in quality or performance and able to be trusted. My wife is a psychologist, and I asked her when I say reliable, what do you think of? Her background suggested that something is the perfect example of reliability, or something that is reliable, is a tape measure. They said that is anything that you can use to measure the response or a particular situation is deemed reliable. However, it's not necessarily always deemed as valid, which is probably yet another discussion altogether. So when we talk about reliable software, or reliable systems or organizations, we're talking about a system or a person or software that is responding in a way that we're expecting, and it's always there. Now, what's interesting about reliable is that there's many different things about reliability that make up something to be reliable, which is why we kind of made it a parent attribute. So one of the first attributes within that kind of contribute to that family of reliability is the attribute of being durable, able to withstand wear, pressure, or damage, hard-wearing, and long-lasting. And so James and Matt, they're here in the room, they might recognize the attribute of longevity. And as I was just been staring at this and thinking through this topic, I've replaced longevity with durable, because durable is something that lasts a long time. But it also has a few more assumptions about it. For example, when we think about software in automobiles, and Josh Corman is looking at this a lot right now because he's interested in software as it relates to public safety and the responsibility that we have of software developers putting consumer products and similar physical items into our customers' hands. So, but a system that is not unreliable, that is an automobile, for example, could potentially catastrophically fail just with a fender bender. As we're starting to look at some of the wearable technologies that are coming today, anyone heard of Tizen? Tizen? Yeah, created by Samsung. So that's an automobile quality, rugged version of Linux, which is being placed on watches. And so we know that these watches are going to be banged up against walls and misused and abused, not necessarily by way of a hacker, although I'm sure that will be true. They need to be able to withstand being dropped and banged around. I think we all are familiar. Actually, this is something that I just recently heard, believe it or not, I think on NPR the other day. But we're starting to create self-healing concrete, which is almost impossible to believe, but it's true. So there are real-world examples of actual physical items that can, in fact, self-heal. This particular concrete, part of its self-healing nature is that it actually breaks into various micro fissures instead of larger cracks. So the idea of something being durable means that it is bendable. And so we all think of Bendgate at this point, right? So it's sometimes when you look at items like this, it's hard to figure out, well, how does this work in the software world? How does something be durable? But these particular components, consumer products, we carry them around in our pockets. And so the normal wear and tear, they'll be found in the real world in our pockets. And so they need to be able to withstand, tight jeans and sitting for long durations of time. The first thing that I thought of is the Great Wall of China, right? Because it's been around for 7,000 years. Not all of the pieces and parts have been all lasting along that long, but the majority of the wall that we still see today was just built during the Ming Dynasty, which I think was less than 100 years ago. But there are components of the wall that was built 7,000 years ago. I was watching a program on the History Channel the other day about the 101 top inventions, and wooden pegs is in there. What's interesting to me about wooden pegs is that some of the oldest man-made structures on the planet today are made with wooden pegs, which to me is just, it blows my mind. But at the end of the day, it's because if you place a bolt, we all would think that a bolt is going to last, a wooden bolt is going to last longer than a wooden peg. But the idea of wooden pegs is that they'll expand and contract at the same rate and the same amount based on weather as the structure around it. So the peg and the structure itself are both adjusting at the same rate. So then the overall component stays together. And if you haven't heard about the 10,000-year clock, it's being designed now, sponsored by Jeff Bezos of Amazon. And they're actually building a clock that they intend to chime, I think it's once a century, then once every 1,000 years, and then there's going to be a cuckoo that comes out at 10,000 years. Nobody really wants a clock just to have a clock that lasts 10,000 years, but the idea is to adopt this long-term thinking, to think about what it might look like if we started spending more time focusing on quality of the things that we do, the products that we build. It's the exact opposite of these cheap toys that we buy that last, in some cases, less than an hour. It's one of the most frustrating things for me as a parent. What's interesting about this 10,000-year clock is it's actually going to be built in a mountain. I think it's like 2 stories tall, and it's going to be here in Texas, in West Texas. So someday when they get it built, it will actually be a tourist attraction. But if you can imagine the amount of engineering that's involved in creating something that will last that long. Something must be available in order for it to be reliable. It must be suitable and ready for use. And must be of use or service and at hand. So I used to think of software as needing to be scalable and used to talk about scalability a lot. But scalability is something that contributes to software being available. So scalability itself is not an attribute, but certainly is part of a contributing factor of availability. And a real world example is a butler who's always there, or a lost puppy dog, right, who's always just following you around and being available to do whatever it is that you want at any point in time. There's a lot to be said for software that where the engineers have spent the extra time to engineer it in such a way that it is available. And what's most embarrassing is when software is not available. And there's been a lot of study in the user interface and user experience area that when software is built and the big announcement has been made, thousands of people come to view the software, and if it's simply not there, if they get a 404 or if it's broken or if it's particularly slow, they simply won't come back. And that may not be our primary concern as security experts, but at the end of the day, it's to our investors and our stakeholders. It is the most important, one of the most important. So recoverability is an interesting one. So the idea that even if we are Batman, we are going to fail from time to time. We started today's session by watching Batman get his butt kicked. It does happen. We've all had failure in our day. But we must be able to recover from that. When it comes to software, a good example of software that is recoverable is software that has an agent that just checks to see if other software is alive and ticking, and if it's not, it restarts it. One particular scenario that I heard with regard to recoverability is where multiple nodes would go down, and then they all had the exact same retry recoverability algorithm. So that would retry in 5 seconds, and then 15 seconds, and then 1 minute. And when all of the nodes went down, 5 seconds later, they all tried to come back up at the same time. And then they, of course, wouldn't succeed. They wait 15 seconds, and then they all try to come back up. And so eventually, a human had to get involved and say, well, let's get this thing spun up one at a time and get things going. And a good example of that, which I didn't think of at the time I was putting the presentation together, would be the energy grid that we use here in America. We've had many, many blackouts due to the lack of reliability or recoverability of those energy grids. Survivability. Now, so here's where we get into something that's a little bit more abstract, and I might already have your mind spinning a little bit because some of these seem so related. Survivability is a really good example of where we've said, okay, even though this particular attribute could be interpreted by others as meaning something else, for the sense of being rugged, for the sense of understanding rugged and implementing rugged, let's talk about how survivability specifically has to do with capable of withstanding attack, but perhaps more importantly, to remain or continue in existence or use. So for here we talk about, well, I'm not even going to talk about that. Here we're thinking about perhaps like a reliability or dependence on a third-party system. So if you have built a system that is reliant on that third-party system being available and then discover that it's not, then your system needs to be smart enough to know how to react to that system not being available, and to gracefully approach the situation rather than the blue screen of death, right? Approach the user and explain to them, this particular service is not available. We can email you, we can SMS you, check back in 5 minutes, something along those lines. Everybody knows the idea of survivor. In this particular case, we've got someone anyone ever do bungee cord? I've always wanted to do it, never had the opportunity. But in this particular case, we have them doing bungee over water, which is smart, right? Because you don't want to be 100% reliant on that particular cord. So the idea of implementing a safety net in your system, a safety net that says, if this should fail, my users are going to end up here. How should I handle this situation in such a way that I don't detract from their experience to such a degree that they won't return? Or worst case, they'll actually tell folks, don't ever go there because that was a terrible experience, it didn't work for me. So let's think about a real world example of in mobile development. So we run into those a lot in application development. The idea that we need to be able to extend a user experience to our customers, but we cannot rely on the fact that Wi-Fi is going to be available or that cell service is going to be available. So then we're immediately put in a situation where every single line of code that we write, we have to think about what is the state of our connection to the world. And I think this is really a good point to suggest that when we're talking about rugged isn't necessarily just looking at security and reliability and maintainability and coming back after the fact, after a product has been designed, and concerning yourself with those attributes at that time. When you're writing software, you need to be doing it with the idea of security and reliability and maintainability in mind the entire time because of this responsibility that we have. It's hard to go back in time and undo something that you've done wrong. Predictability is an interesting one. Again, we're talking about the overall reliability of a system. I found some really good examples of predictability in total quality management, which is something that exists more in the manufacturing world. And so the idea here is that when you're manufacturing, for example, bricks, the process around the implementation and manufacturing of those bricks must in itself be a reliable and rugged system. With the reason being that if these bricks are not all evenly baked and they don't all behave the same way, then any other future product that's built down the road with these subcomponents will be also unreliable. So there's that adoption process that kind of happens, or inherit process. So there's a lot we can learn about total quality management. There's a lot we can learn in the software world about quality. I'll say you that. So Lego's a great example that I have going on at my house right now. And this is a great part where we can talk about all of the cheap toys that there are out in the world. Lego has been around for a long, long time. I think it's over 100 years. And they almost went bankrupt, completely bankrupt, in the early 2000s. And part of the reason is because they started jumping out into other lines of products, other lines of toys, and they started innovating in so many different ways that they practically bankrupt the company. But the reason they were doing that was out of fear, because their patent for their brick had expired. And so now all of a sudden tons of competitors were coming in and replicating what they were doing. But what Lego forgot was that they had already invested literally millions and billions of dollars in engineering the best brick. And that's when they realized, we just need to continue to be the best. And so that's what they're doing now. But I can tell you, when I discovered this about Lego, I had Mega Blocks and some other blocks that were in my house, and the kids never played with them because they didn't have that same reliable click every time. I gave them away. I sent them to Goodwill, and I bought more Legos. At the end of the day, we're talking about predictability, the idea that when you take one block and place it on the other, that predictable behavior needs to be there. But there's a catch with predictability, though. Predictability isn't always necessarily a good thing. So let's go back to our scenario here where we're talking about defensibility or sensibility, and asymmetric response. So part of the thing, when I mentioned predictability to an associate of mine who has a strong military background, he always thought of predictability as being a very, very bad thing. Because now we know where that guy is. And if he's there every time, you know, his effectivity has gone down to almost zero. So they have to remain unpredictable in that particular case. So this particular attribute needs a little bit more research. I think it's going to be conditionally something that needs to be done needs to be done conditionally. Not all things should be predictable. And as you guys know, in the world of security or military, predictable behavior can be used against you. So questions about reliability. Cool, we got about 10 more minutes. I'm going to shoot through maintainability. So I end up spending a lot of time in my world working on maintainability because we've adopted a lot of different software systems, and not all of them are ones that we've created. There's a lot of bad software in this world, or poorly engineered, poorly designed software. It's a bit of a problem, an epidemic in my mind. If something is maintainable, if you can keep it in an appropriate condition and keep it unimpaired. This is not very easy to do. The ideal world, everything would be built of such great quality that it rarely needs repaired. But at the end of the day, that doesn't happen. So this is what I think of when I think of maintainability. And this is an access panel for the back of a shower or a tub. And when this system were designed, they knew that at some point they were going to have to maintain it, so they built an access panel. All systems need to have a way to easily get to the various components of the system that need to be tweaked in order to change the behavior or in order to fix or repair a system. There's a lot going on with that, believe it or not. There's various standards. The idea of convention, when he opens that access panel, he's pretty sure he knows what he's going to see and he knows how to repair it. The idea that something needs to be agile is huge. It's very, very difficult to maintain a system that is not agile, marked by an ability to think or change quickly. My favorite example here is I love border collies. I'm not a particular fan of watching dogs run around and do stuff, but whenever I searched for agility on Google Images, it was just littered with dogs, because I guess they do a lot of agility training. What's particularly interesting in this case, I think, is the fact that while this dog is actually jumping, he's already looking elsewhere and thinking about what he's going to be doing next. And that makes me think of Batman or Bruce Lee. Agility is very similar to flexibility. This makes me think of Ruby on Rails, the way that it is an agile web development framework. It's built on convention, similar to the access panel. A developer will be able to go into a system built on Ruby on Rails and will know where everything is and know where to go to tweak various things. But at the end of the day, agility really is about being able to change what already exists. And so this makes me think of the lean startup community. So the idea that if we go out and validate that what we're building is in fact not really what the world wants, then we can quickly change it. The software needs to be able to change as the vision for it changes. The idea that we should be able to build something without knowing exactly what it is that we're building, we need to be able to start today and go as fast as we can. Portability, capable of being transported or conveyed. This is what I thought of when I thought of portable. But that's actually not really a very good example. It is not a bad example, but it's not the best example. So the containerization that we underwent in the transportation industry is extraordinarily interesting to me. It happened right after World War II. The idea that we need to be able to move cargo on boats, on rail, on the highways, and we need to be able to have a standard across the globe to do commerce with internationally or globally. So containerization, what does that mean in the world today? There's a lot of trend going towards containerization in the cloud, and so the idea of being able to implement a system in more or less a black box, and while that hardware will continue to degrade over time, you can quickly grab it and install it on a different operating system in a different environment as quickly as possible with as low overhead as possible. Something needs to be observable. These are a couple of attributes that we added here just in the last 6 months or so. So the idea that software, in order for it to be rugged, you have to be able to observe the health of it. You can't just launch it and be blinded. You can't you can't quantifiably explain to your customer that things are going well or not going well if you don't have that observability. How do you know if you're being attacked if you can't observe the health of your system? And we all know that there's a number of different systems out there today. If you're not running something like New Relic on your application, Brakeman, there's lots of options out there. But observability is clearly, in my mind, required in order for software to be rugged. But you can't just be able to see it, you need to be able to control it. I don't know if you noticed, but in this, I wanted to make sure that we found something that didn't have any buttons. And so here we have buttons, the ability to actually be able to change the behavior of the software. And so I liken this to configuration variables. Software needs to be able to, or I should say, the stakeholders or owners or developers or engineers who are working on software need to be able to change the behavior of software without doing yet another code deploy. As we all know, things can change when you deploy new code. And so, especially if you've got like a 2-week agile life cycle and you're having an issue in the system today, you need to be able to change it quickly. So this is used in larger situations in the cloud when you have thousands of users and you want to deploy a new feature. Before you deploy it to everyone, you want to make it available to everyone whose last name starts with A, and then make it available to everyone whose last name is A, B, or C, and then eventually scale it up. And you're doing that for a lot of reasons. You want to make sure that it doesn't put undue stress or load on your system. You want to make sure that people like it, etc. And so you can do that with code deploys, but you can do it easier if when you're developing it, you're pointing to environment variables or configuration variables that are adjusting the behavior of that ramping feature. 5 minutes, right? Okay, so we're almost done here. This is the other example of controllability, and because I live in the software world, I didn't really think about this. I don't know if you can quite tell. I use this as an example because the Apple TV is a lot like a black box. But as I'm thinking about configuration variables for software, it occurred to me that black box software can be very much that same way, and it's true with the phones that we have in our pockets, right? They have settings, and those settings can easily change the behavior of the software itself. So just think of it as being yet another way to change the behavior of your software without actually having to release new code and potentially break or damage an experience. So moving forward, I think there's some additional areas that we could look at for rugged. One of them is looking at whether or not a system is usable or accessible. These weren't originally part of the thoughts for rugged, because the idea of rugged kind of came from the security world. I spend more of my time talking to usability experts than I do security experts, and they have concerns about whether or not something is usable or accessible. If it's not usable or accessible, it certainly will not be available to some. And so maybe these are just contributing areas to availability. But I'll suggest to you that maybe we talk about something that, adding another parent level attribute, something that needs to be secure, reliable, maintainable, and usable. So back to Batman. Here's my call to you. The idea of rugged is more than just a scientific project. It's more than just trying to understand how we can build better software, but it's actually stepping up and doing it. So I grabbed a couple of quotes from Batman. If you make yourself more than just a man, if you devote yourself to an ideal, you become something else entirely. But it's not just that. It's not who you are underneath. It's what you do that defines you. And that's really the challenge. It's not just to believe in something or to buy into this ideal, but to actually challenge yourself and challenge those who you work with to do it and do it better. And so I ask that all you, in terms of a call to action, please visit ruggeddev.org. There's our Twitter account. We're working on blogging more, adding more to the content, and we welcome contributors. So thank you very much. But in my mind, when we talk about like Ruby on Rails, that there's a certain way to build software, and we have kind of all crowdsourced that agreement or that approach. Yeah, so it's almost like you need to be conditionally predictable, right? If you're dealing with a system that you trust, then you can be predictable. Anyone else, maybe you should be unpredictable. You should confuse them, like on purpose.
So I have a question.
Yeah.
So you mentioned maintainability or maintenance.
Yeah.
I'm a quality engineer, and one of the things we look at is measurability of the software.
Measurability.
Is there a way that you look at being able to measure the software to determine how maintainable it is?
Well, so we've talked about the idea that as we work on rugged, that maybe the end result is, once we can all agree on what it is that rugged is and how it affects the world that we live in and the software that we work on, that maybe it does become a framework and a scoring system so that you can run your system against this rugged protocol and find out that it is not rugged at all and you should start working here. Wouldn't it be great if we had that for OWASP, right? What's your top 10? We all talk about we need to pick one of the OWASP top 10 and just start working on that one. Well, which one do we start with, right? Yeah, I think you have to focus on their pain, and if they've been developing for a while, they'll probably have experienced enough pain working on systems that are highly configured and highly bespoke, so incredibly different than anything else that there's a huge learning curve involved. And so maybe it's not the individual developer, maybe it's the product owner who then, because of the normal nature of turnover with their folks, that every time they bring on someone new, it's weeks before they really understand what it is that they're working on. It's almost like the only way to really get anyone to believe in rugged is to get them to focus on their pains, right? All right, thank you everyone. Appreciate it.